So fine. So starting from here, RAG. So RAG is a method where an AI model first finds relevant information from a data source like documents and then uses that information to give a better and more accurate answer. It's a application of Gen AI. And starting from this evolution of LLMs. So LLMs are large language models, and the first LLM was simple RNN, recurrent neural networks, which used for handling sequential data. But there are also some limitations, like it has struggle with long sentences when using gradient descent. So gradient descent is basically an optimization algorithm, isn't it? So it fails to optimize some kind of uh, process in the backend. So neural networks is similar to the neuron that our brain has, and loop architecture output of one step is passed to input to the another step. As you have already know that recurrent neural networks works on the sequential data. So one output can be passed as an input of another step. Then comes LSTM-RNN. LSTM stands for long short-term memory. Okay, and RNN is
Mm.
still recurrent neural network. So long short-term memory, it can remember long and solves VSD sequences. So it has slow to hair, uses more computational power. LSTM basically uses more computational power, and RNN, LSTM and RNN is remembers information for longer time, uses gate architecture, input, forget, output. So gate architecture, OR gate, AND gate, this kind of gate architecture. Have
Yes,
you heard
yes, yes.
about this? OR gate, AND gate,
Mm.
NOR gate.
Mm.
So basically, these are the evolutions. Like then after LSTM RNN, then GRU RNN came, which were faster than LSTM and simplified version of LSTM. It has fewer gates, reset and update gates only. And then bidirectional RNN came. So bidirectional means reading a sequence from both direction, forward and backward. Like Google has already previously previous to Gemini version, Google has launched BERT in 2018 or 19 maybe. BERT, you have heard about BERT?
Yeah, yeah.
BERT, bidirectional encoder and representable transformer. This kind of maybe the word's full form is. Have you heard about that? So
I don't know the full form of it, but I heard about it. Yeah.
okay. So BERT is basically bidirectional means reading a sequence from both forward and backward. Let's suppose you are reading this
Okay.
line, this sentence. So when we are passing this to a machine, any natural language processing machine, it reads one from a starting and another from back. Okay. And then it can able to understand the whole context of the sentence. So that was like cross verifying the sentence by reading it from two sides. Okay, it basically improves the accuracy in many NLP tasks. Like it has been observed, like when you are reading the line, when you are passing any natural language, means English language or any other language to a model, if it reads from the single side, then it understand the context, and then again when it was done in such a way that like it reached the sequence from both direction, and then the result was compared with these two, and the observation was when we are following this bi-directional approach, our accuracy has increased in many NLP tasks. Okay, so this was the evolution, and then after encoder and decoder architecture came. Encoder and decoder is very recent. You can say that like 23, maybe 2022 or 2023. In these years, this architecture has been into the picture, and these are basically computationally inefficient, handle variable lengths, input and output, and when input output are of different length, these models are used, and then uh, text summarization and other kind of applications has been also be considered in this encoder and decoder architecture. Basically, these are the recent architectures which has been followed in many deep learning models. And after that, self-attention model came. Okay, self-attention means it is like focus on important words in the sentence. It is talking about natural language processing, but if you will understand in images, so you can understand like self-attention are focused on the only part that we are going to train. So I'm just giving you one example here. What is self-attention? Maybe you can. My screen is visible, na?
Yes, Aditya.
So I'm writing here.
Now it's not visible.
Now it's not visible.
Yeah.
Wait. It's visible.
Yeah.
Actually, we are talking about self-attention, na?
Yes.
Self-attention is, when we are talking about any NLP, natural language processing, NLP.
Mm-hmm.
So in NLP, self-attention means like you are writing some words here, any text, okay, and you are detecting the sentiment. So you will be only focusing on what? You will be only focusing on, yeah. If you are finding the sentiment of this text, you will be only focusing on the verbs or maybe uh, the words inside this sentence which are more aligned towards the meaning, because there are some subject like he, she, or maybe they, isn't it? So they are not playing any role in getting the sentiment, isn't it? When we are working on
Yes.
normal machine learning model, we used to pass all the data to a machine learning model and then get the output. But in self attention model, we used to extract the main words out of this whole words, like we will reduce the subject, or maybe we will reduce the object of the words, like any table, chair, or car has, if anything has been discussed in the whole part, we will simply deduct that, and we will simply extract out the main words out of the sentence which are basically emphasizing on the sentiment of the user. Okay, so this is like self attention. So if I'm giving you one more example through an image, let's suppose you are detecting power lines, you understand?
No.
Power line means the lines which used to pass current in a village or urban areas. Traffic poles,
Okay. Okay.
you have seen poles and power lines. So you have
Yes.
to
Yes.
detect power lines. So when you are passing this whole image to the model, it will see all the things like poles and vegetation, maybe something above the things like trees, or maybe birds and others. But when we are passing through any self-attention model, it will simply reduce all the backend part and only focuses on this part only. Okay. So this was later introduced in order to reduce the complexity of the computation. So that's why self-attention model has came into the picture, and right now these are very much popular. Self-attention models are very much popular. So here you can see focuses on important words in a sentence in terms of natural language processing, check all the words at once, and gives high importance to the relevant words. And here you can see remember the long sentence better than RNN. These are the advantages. Use a lot of memory for the long test and compute in efforts. So after self-attention, transformer models came. So these are very recent models. Transformer, you have heard about this or not? Listen about transformer.
Heard about transformer. Yeah.
Okay. So
Transformer, lang chain, lang graph.
yeah, correct, correct. So
Mm.
it is extremely powerful for long texts. Okay, for natural language processing, it's extremely powerful. It replaced all the RNNs and LSTMs. This is the more recent, means like after 2024, the transformer architecture came into the picture. And right now, all the
Mm.
researches, all the AI field is completely revolving around this transformer architecture. And here I am going to show
Mhm.
you one website where you can see multiple transformers. First, you need to understand what transformer is. Transformer is basically, you've heard about GPT, generative pre-trained transformer. Transformer is a big model of here. This is a website where you can get multiple pre-trained transformers. Okay, Hugging Face it is. So here you can see there are open source, this platform where machine learning community collaborates on model datasets and application. So multiple transformers and deep learning models are available on this website. So in case if you are working on any project, you can simply refer to the website, this website, and find multiple free transformers like Minimax, text generation transformers, and NVIDIA's. These are open source. If you wanted to search for any particular task, like GPT is a kind of big transformer, like multi-modal transformer, which can generate text, which can also create text, which can also image to image, text to image, and all this can be performed inside one model, which is Chat GPT, Gemini, and other LLMs. But if you are working on some specific task, like if you are working on image text to image, then you can refer to this is also multimodal, so you can refer to this models. You can see, and here if I'm going to this model, you can see here we can see the download part where you can download the trained models and utilize that model for your data set. Or you can simply, from here you can go and open in the Google Colab, and you have to create your HF token. So when you will create your account here, you will get a API key or maybe HF tokens from here after creating the account from this website. And this is very much useful if you are working. See here, you can see these are the codes which has been provided, and you can simply change the message here and see the output. Maybe the HF token will ask to submit. I'm not sure about this. I need to change the runtime. Do you know how to run the code on Gemini? Means Google Colab.
Google Collab, huh?
Do you know
Yeah,
how?
I tried one.
Actually, you
Yeah.
need to change the runtime. From where we can change the runtime?
Let
Here
me
you
just
can
look
go
into it.
change runtime, and you can select T for GPU, because if you not
Okay.
change this, it will be automatically set to CPU. So for using any
Okay.
GPU model of Gemini, sorry, Google Colab, you can use this link. Or maybe if you want to use TPU, TPU stands for
Okay. Don't know it, yeah.
tensor flow, maybe tensor processing unit. TPU stands for tensor processing unit. Yeah. So GPU is
Okay.
graphics processing unit, and TPU is
Okay.
tensor. It's a kind of 3D, matrix and then tensor.
Yeah, yeah.
Yeah. So that's so here this website you can see for many kind of transformer, for multiple transformer if you get here. And coming
Mm,
to the topic again, so this is the foundation to get into Gen AI and work with LLM models. So transformer is very powerful
mm,
model. Okay, it can
mm,
process lots of data, and there are architecture behind this. So coming to the generative AI, in the previous session I've already discussed this part. Like AI is a big whole picture. Inside that, machine learning came. Inside that, deep learning, then Gen AI. Okay, so if I'm going to ask one question to you, let's see here. Uh, Calculator, I've already asked this question previously as well. Calculator is also do what? We give input and it give output. Okay,
yes.
calculator. And when we are talking about any ML model, we
Mm,
give input and it gives us output. So how
yes.
a calculator is different from AI ML model? We say a calculator is also an AI?
No, calculator is not a.
Correct. But can you define me the exact reason why calculator is not an AI? And because we are doing the same thing now, we are giving input to it and taking output. But ML model, we are
Mhm.
giving input, getting output. So what is the main difference between a normal calculative platform and a different AI ML model?
Based upon the input which we are giving, right?
Yeah,
It will rethink and then give the output of it. And then calculator doesn't do that.
yeah, you are pretty much correct because calculator has some predefined functions. Okay,
Yeah.
so the rules it perform on binary operations. Like if you are adding 3 to 5, so you will simply write 3 means 1 1 and 5 means, isn't it?
Yeah.
No, it's not 5, it's 7. 5 is 101. Okay, you know how
Mm.
to convert any number into binary.
Yeah. Yeah. Mm.
So adding this will get 3 plus 7 is 10. So 10 means 1010. So this is 10.
Mm.
Okay. So
Yeah.
you can see here calculator is simply adding a binary calculation. It's not doing any kind of prediction or what we can say generation. Okay. But when you are giving the same thing to any AI model 3 plus 7, it will not do like this. Okay, it will not do like this. It will simply go and check out the previous data set and connect the dots between their neural networks. Okay,
Mm.
and then we will get output as 10. So inside this,
Mm.
you can say this as a black box. We don't know what actually happening inside this. It's just finding out the pattern. Like it's know that 3 plus 6 is 9, 3 plus 4 is 7. So by
Mm.
relating all this, it can calculate 3 plus 7 is equal to 10. Okay, so this is the
Okay.
backend
Mm.
architecture of any DL model or yeah. So here you can see machine learning perform a statistical analysis, visualization, prediction, and forecasting on data, understand the data. So generative AI is kind of two types. One is discriminative and another one is generative. So discriminative means classification prediction trained on label data sets.
Okay.
Previous class, one thing I've told you, na, three types of learnings: supervised, unsupervised, and reinforcement.
Yeah. Yeah. Yeah.
Do you
Mm.
remember?
Yes. Yes.
Okay, fine. So generative AI models are one is classification prediction, like trained on label data set. It's part of supervised learning. And second one is generate new data from the huge data set which was used from the training. Okay, like it was new. Till now, what AI was doing, AI was predicting. Okay, you are
Mm.
let's suppose you have trained your model with thousand of images of what
Mm.
of leaf detection, disease detections. Let's suppose you are working on any leaf disease detection project. Okay, so you have
Mm.
given lots of data of leaf diseases, like this disease is some part of this is that, this is that, and you have labeled that this is a kind of A disease, this is a B type of disease, this is also A type
Mm.
disease, and all the images are in the training data set. This is also C type disease, and west and then you have trained your model, and after that you have given a new data like new image with some kind of disease you don't know, and you have given this disease this images to the model trained model, and it gives you output
Mm.
like this is A disease. Okay,
Mm.
so what you are doing, you are predicting
Okay.
based
Mm.
upon the data set, you are giving your input, and this model is predicting. It is not generating
Mm.
anything. But let's suppose you have trained your model in such a way that you are now planning to make a new image from all this. So what you are doing, you are generating, like you have given thousand of images of bicycles. Okay, and now you
Mm.
wanted to make a new bicycle which was not existing in your data set. So what this model is doing, this is basically connecting the dots from all this and making some kind of new version of a bicycle. Okay,
Mm.
which was not exist. So in this case you are generating.
Okay.
So this is the two type of artificial intelligence. One is classifying and predicting, and second one is generating. So generating is, you can
Okay.
generate text, you can generate images. So generate new data is kind of still one thing is there, like generating new data. We say that we are generating new data, but it is basically related to the past data sets. As humans, we can generate new data which cannot be linked with any kind of past. But in generative
Mm.
AI, even we are generating new data, but still it has some relation with the past, isn't it? It cannot
Yes.
generate beyond the box. It has some limitations. So here you can
Mhm.
see AI means build application that can perform its own task without human interruption. I hope I am
Okay.
clear. I've discussed all this in the last class by defining you the four levels of automation where human.
Mhm.
Do you remember this? That PDF I am going to show. This one, analytics maturity, we've discussed now.
Mhm. Yeah.
So here I have discussed about four levels of automation, like how the things work, and if we are completely eliminating human interventions from the operation, we can say that it is 100% automated. Okay. In driverless
Okay.
car, I have given you example of driverless cars. Like one automation is automating the gears. Second automation is automating the second means accelerators and all. And the final automation is removing the driver and making the things completely automated. So deep learning, here it is. So this kind of neural network uh, happens in between the prediction, like input, output, and this kind of feature extraction features. One video I will share to you, which was which is
Okay.
on CNN, convolution neural network, that has a
Okay.
pictorial images, pictorial visual representation of how CNN architecture work. So I will share it to
Mhm.
you on WhatsApp. You will see, you can see that to get better picture of how things work behind the. So here you can see how. So AI means build application that can perform a task without human interventions. And Netflix is a recommendation system which is a part of AI. Self-driving cars are also an example of AI. Deep learning means is built to mimic human brain. Okay.
Okay.
Wanted machine to think how human thinks. So deep learnings are ANN means artificial neural networks, CNN means convolutional neural networks, and RNN means recurrent neural networks. Majorly, we have these three types of deep learning models. So ML can be solved using ANN, artificial neural networks. Object detection and computer vision kind of application can be done through CNN. And text related use cases, time series use cases, that can be performed by the help of RNN and its variants. Okay.
Okay.
Yeah. Now coming to the LLMs. So as of now, the majorly service providing for large language models are these four big tech, that is
Mm.
Meta, Google, and Anthropic. So all these models are like GPT-4 and now GPT-5 and 5.2, 5.3 versions of this. And if you will go through the premium versions of GPT, there are a lot more. So Meta has Llama 2 and Llama 3. Google has Gemini, and Anthropic has Cloud 3. So these are the pre-trained model because these are trained on huge amount of data sets. So we can use this model for domain specific use cases. So fine tuning is a word. To use this pre-trained models for domain specific use cases, we should fine tune. It will be with custom data set. Like you have pre-trained model and you wanted to train based upon your custom data set, so you can fine tune. There are some code I will show you how to fine tune. Now coming to the main part, LangChain. Okay, as per your project that is required, LangChain is important. LangChain is a framework which is used to perform multiple type of applications in generative AI.
Mhm.
So it's a framework which help us to work with LLMs. So now I am showing you the website of LangChain,
Mm.
LangChain documentation. Yeah, this website you should refer. Okay, here you will see LangChain Python. Yeah. So LangChain is an open source framework with a pre-trained agent architecture integration for any model, so you can build AI agents that can adapt as an ecosystem. So here you can see the documentations of agents and all the things. Uh, I hope you cleared about what is agent. Do you know what is agent?
Agent.
AI agent.
Yeah, I know it, but then not clear it. Mm.
So I'm showing you one thing here.
Mm.
I hope my screen is visible now.
Yes, yes.
So here you can see AI agent is here in the VS code. You can see AI agent is here.
Mhm.
So this is
Mhm.
Codex. Codex is a tool provided by ChatGPT, and basically
Mhm.
when we are giving any prompt to ChatGPT, it generate or it suggests any solution. Like you have to do something like that, something like this. Okay. But when we are talking about agent, and if I'm writing something here, like my error or whatever it is, so it will automatically edit all the lines inside the code. I just only need to
Mhm.
accept. Okay. Means agent is
Okay.
actually working based upon your prompts.
Okay.
Okay, like ChatGPT or any model is giving you the answers now or suggestion, like you can do something like this, something like that. But agents means
Yes, yes.
actually doing the things. Like let's suppose my error
Okay.
was something this. Okay, so something like this. So I have given the prompt, not prompt. I've simply written here like something in my terminal is not working. I will help you to install all this setup in your VS Code as well if you wanted to do something like this.
Okay.
So by this you
Okay.
can simply, you don't need to screenshot and paste it to any chat GPT. Simply you are working on your project
Mhm.
and whatever error will be coming to your terminal, you can simply type here
Mhm.
like how to resolve this error without taking any screenshot. The agent will automatically understand because it is already shared with it. The agent is seeing your code,
Okay.
agent is seeing your terminal errors and all this.
Mhm.
So it can simply understand that what error is happening and suggest,
Okay.
not only suggest you, but actually implement those changes inside your code, and you just need to accept only. The accept button comes at every line where the AI agent done the changes. Okay, so
Okay.
these tools like Roo Code and Codex can be very useful to increase your
Mhm.
productivity in projects. Okay, so maybe in April month you are getting the project related to AI.
Yeah, yeah.
So you can set up these tools in your working environment. It can help you to perform all these tasks.
Mhm.
Okay, I
Okay.
will help you to do that part also. So now coming to
Okay.
how
Okay.
ChatGPT is trained, just a basic overview. I'm not going deeper into this. Stage one is generative
Mhm.
pretense like base GPT model. Second is
Mhm.
supervised fine tuning. Then fine tuned
Mhm.
ChatGPT model. Stage three is reinforcement
Mhm.
learning. Reinforcement learning is like what we are giving to the ChatGPT is still learning now, like
Yes.
human
Mm.
feedback. Like we are interacting with the chatbot. So this is also part of learning with ChatGPT. And then finally ChatGPT model came. So these are the four stages, three stages actually. And the pre-trained data set has been, the data comes from multiple sources like website articles, Wikipedia, books, research paper, etc. And generative pre-trained, internet, huge data source, transformers, base GPT models, long transitions, long translations, text summarization, text compilation, sentiment analysis, conversational chatbots. So these, yeah, I will share this notes with you also. Okay,
Okay.
So you can simply revise or understand if you want. Reinforcement learning,
No idea.
reinforcement learning is a one learning algorithm. I'm just explaining
Mhm.
once again the three. I, in ML, I have explained, there are three types of learning. One is supervised learning,
Yeah, super reinforcement. Yeah,
unsupervised, and reinforcement. So in supervised
yeah.
learning, we basically, let's take an example of a child. Let's suppose his father is teaching him. Okay, his father is teaching him
Mm.
by saying that this is dog, this is cat, and this is horse. So
Mm.
this child remembers like this is dog, this is cat, and this is horse.
Mhm.
Okay. Another times a child is there, but there is nobody to tell that what it is. But even if,
Okay.
even though he can able to categorize that horse in one section, cat in one section, and dog in one section, he does not know that this particular thing is dog or this particular thing is cat, but he knows that these two are different. Okay. So in
Mm.
some
Mm.
cases where supervision is happening, that is part of supervised learning, means you are training the data with the label data set. Like this is cat, horse, and dog. These are labelings now over the data. In unsupervised,
Yes,
you
yes.
are training the model without any label data set. Means you are just
Mm.
giving the data and let model decide that which category it falls. So there are algorithms like k nearest algorithms, k nearest neighbor, KNN models. So these are unsupervised learning. And reinforcement means it's agent based model. I have shown you a video of agent, that hide and seek on YouTube, hide and seek video. Do you remember that?
No idea.
Maybe yeah, this one. OpenAI. This video is an example of reinforcement learning. Okay,
Mhm.
so I'm sharing you the link of this video. If
Okay.
you get time, you can see this to understand what reinforcement learning is, just for a overall understanding. Okay, these all are
Okay.
things I
Mm.
am sharing with you because right now, if you have a clear idea about all this, now you can able to find out solutions. Okay,
Okay. Okay.
you can get
Mm.
that. Oh, actually, this kind of thing is there in the machine learning, so we can get out of here. So a
Mm.
basic overview I am giving you right now, that
Okay.
things are, because even if you are getting some projects which are difficult, so you can find out
Mhm.
that even you should able to find out the solution. Even if you are not getting
Okay.
solution by yourself, you should get this, you can
Mm.
find out the solution by knowing that this kind of things happen or this kind of things are there available. So if you get time, just watch that video. And for basic overview, I'm just explaining you reinforcement learning is basically learning by hit and trial.
Okay.
Hit
Mm.
and trial means first the model will do mistake and you will
Mm.
correct him, then again it will do mistake, then again you will correct him, or if you will do it correct, then you will reward it. Like chat gpt, human feedback, isn't it?
Yeah. Yeah. Yeah.
Like
Mm.
chat gpt given some answer and you have said no, this answer is not correct, so chat gpt acknowledge, and next time when you ask that answer again, chat gpt accomplish that feedback, isn't it? So
Okay.
this is a part of
Yeah. Yeah.
reinforcement learning, like trial and error.
Mm.
You are not training in the data set, you are not training by any labeled data set or unlabeled data set, you are just training by agent based learning, we say it's okay. Like
Okay.
you are training based upon the trial and errors, like correcting the model every time. So this is how the things are. Now coming to llm's evolution, so these are the years, just for a understanding. 1967 starting to this 2017 the research part, and now OpenAI and multi models are there. Okay. Okay,
Mhm.
right now self-supervised learning are also came into the picture. So major company which are building LLMs are OpenAI, Google, Meta, Mistral. These are the companies. Databricks, Snowflow. So LangChain right now is the most common framework that is specifically used to build GenAI applications. And Hugging Face, I have shown you the website. It is basically for transformer library, which help us to build pipelines, multiple pipelines. It provide you API key. Similarly, we have Meta Google API key, and
Mhm.
OpenAI Hugging Face also gives API key in order to perform the task from open source platforms. Okay, and LangChain is an open source provided a common framework for acquiring all LM models of different companies and developing this. So now I am coming to your project, which is RAG based project, isn't it?
Yeah.
So just go to this website here, and I'm showing you the whole retrieval. Here you can see
Mhm.
this is the documentation, official documentation of retrieval augmented generation.
Mhm.
Okay, so here you can see LLMs are powerful, but they have two key limitations. One is finite context; they can't ingest entire corpora at once, and second one is static knowledge. Their training data is frozen at a point in time. So retrieval addresses these problems by fetching relevant external knowledge at query time. This is the foundation of retrieval augmented generation, enhancing the LLM answer with context and specific information. I hope you got the answer.
Mhm.
So just
Yes, yes.
let me explain you about the very basic example. Let's suppose you have a uh, LLM, taking any example of LLM, Gemini model maybe, and you have your admit card of any exam, and there are some instruction written like for admit card for exam you must have one pen. Apart from that, you have one Aadhaar card and your admit card. So these are some instruction written over the admit card. But when you go to this Gemini model and ask that what I need to carry for my UPSC exam,
Mhm.
okay, so this model will give you what? It will give you a generic answer which is used to isn't taken by a common exams. Okay, like you have to carry this one or that one. Maybe any a specific instruction written over this admit card which is not common, which is not so common. Okay, in that case this Gemini will cannot answer because it does not know the context, which type of exams you are going to appear and what is the changes in this admit card. So in this case what you can do, you can give this admit card to this trained model, means LLM, and then you can ask the same question. Now this model has some context that you are asking about this particular document, isn't it? Then in the
Yes.
first case it also give an output, in the second case it also gives you one output, but the chances of getting the desired output is higher in the second go, because in this case model know the context, that in which context you are asking this question. So due to this limitation, this is due to this problem, RAG came into the picture, enhancing
Okay.
an LLM answer with context specific information. Okay. So
Mhm.
a knowledge base is a repository or document or a structured data used during retrieval. Whatever the document you are using to retrieve the information. In this case, in this example, you are using admit card, which is a document, single page document. Maybe you can use PPT or other kind of files also. Okay, and you also can prepare your own custom. Let's suppose you have a and gym website and there is a chatbot, and chatbot needs to tell the user that what is the pricing of the subscription of monthly basis, yearly basis, or whatever it is. So in that case your chatbot should know the context, like how much price you offer the subscription. So in that case, what you can do, you can simply make a RAG based application. Inside that, you can give a document in which in that document all the subscription related things or diet related things or pricing related things should be mentioned. And then if any user asks questions related to your company or gym website, that chatbot can easily answer because they know the private data related to your website, isn't it?
Yeah.
So this is basically the overview of knowledge base. If you need a custom knowledge base, you can use LangChain document loaders and vector stores to build one from your own data. So here you can see semantic search is one searching algorithm. It uses to search from the vector databases, and there are four things actually for retrieving any document. Here you can see typical retrieval pipeline. Sources. Sources means just understand by here. I'm not talking about giving any document to any chat GPT or any chatbot. In chatbot, you can simply
Okay.
do like that. Simply upload by using upload file, upload option, isn't it?
Mm-hmm.
But as per your project, what you are doing, you were creating a website in which a user can ask. This is your website. Okay. This is not chat GPT. This is your Streamlit website, which we are going to make, which your project was the first project. Do you remember the Gen AI we are
Yeah.
So that was a Streamlit website. In that website, what we were using any pre-trained transformer, GPT, Chat GPT or Gemini. Basically, in that project, I've used Gemini model. Okay, so I was using
Mm-hmm.
API of Gemini. Means I can ask questions through that API, and this Gemini model responds me with the answer. So what
Okay.
in that case we can do? Basically, the workflow is like this way. Sources, Google Drive, Slack, or Notion, or etc. Sources means from where the knowledge source is coming.
Mm-hmm.
Okay, so just I'm drawing all this. Sources, it can be inside your file also. Maybe if you can see, sources can be directly inside this file also. Maybe you can put the source means document inside your data. Okay, getting my point what I'm saying.
Yes, I yeah.
Knowledge base means sources. Where I was here. Sources, yeah, sorry. Yeah. Sources can be anything. It can be from Google Drive, Slack, or Notion, or maybe inside the same repository where your code is. And then one function is document loader. This LangChain provides. LangChain has a function which is document loaders, which load the document from the source. If it is in the same directory where your code is, then also you have document loader. You just have to give the address and then uploaded the documents, and then it split into chunks. Chunks means
Mm-hmm.
splitting the text into multiple parts. Like PDF or
Mm-hmm.
document has lots of lines, now lots of sentences. So splitting into
Mm-hmm.
chunks and then turn into embeddings. Embeddings means do you know what is embedding?
Embedding heard about it, but I don't know the clear answer.
Okay, so embedding means let's suppose it is good. Good is a word and better is a word. So you know that computer only understand binary language, isn't it?
Yes.
Still we are doing lots of things by computer, chat GPT and many AI things has become, but still the the hardware part is like in the hardware part, computer only understand binary, 0 and 1.
Mm-hmm.
Okay, so still we need to convert this kind of computer will not understand good. Computer will not understand better. It understand the mathematical representation of good or better. So good and better are two different words in English, but the meaning is same, isn't it? Good, better has the same meaning. Agree or not?
Yes, I yeah.
So there is an embedding function which basically convert these natural languages into mathematical representation. Like good is converted
Mm-hmm.
into something like 0, 1, 3, 4, 6, anything. After passing through the embedding function, it is converted something like this. Better will be also converted in the something like this. If the meaning of the two words are same, it converted into the same mathematical representation. That is a part of embedding algorithms that all the hardware engineers are doing. Inside AI,
Mm-hmm.
not only software engineers are working, there are hardware engineers whose tasks are to generate these kind of embedding functions which convert natural language into mathematical operations. Okay,
One
so
minute idea. 1 minute idea.
yeah, can I start?
Yeah, tell me idea.
Wait or start?
Yeah, we can start idea.
Okay, fine. So understood what embedding means? Embedding means converting the natural language into mathematical representation. Okay, a split first
Okay, okay. Mm-hmm.
first loading the document, then splitting it into chunks, and there are also parameters like how many chunks parameter, like the numerical value they can ask in the code. They have the option of adding the numerical value 30 or 40 based upon how much segregation you wanted to make in the documents, and then convert these into an embeddings, and then storing that into vector database. Vector store,
Mm-hmm.
it is a database which store all the mathematical representation of the words inside this. And then here the second
Mm-hmm.
part comes user query. This comes from the interface or the website which you have built, like a Streamlit website in your project. That was a Streamlit website. So user query was
Yeah.
coming through Streamlit, and then it was also it was also passing through query embeddings. Query embedding means
Mm-hmm.
again converting the user natural language, means English language, into mathematical representation, then passing to the vector store, and then combining these two and retrieving the correct answer based upon the user query and based upon the document, knowledge document that the vector store has. And then finally, retriever model activates, and then LLM uses retriever information, and then answer generated on the platform. Getting the type? So this is the retrieval
Yes, idea.
pipeline. Okay.
Mm-hmm.
So this is the overview of the retrieval pipeline, and I think some noise is coming from your side.
Fan noise. Well, turn off the fan.
So here, these are the building blocks in the RAG application. One is document loader. It's very easy. I'm just sharing you the website. All these you can simply go and practice. I'm just showing you one example here. If you can see CSV loader, it's very simple. You can just copy this code
Mm-hmm.
and then open your Google Colab. It's very easy. It's
Mm-hmm.
basically based upon your practicing skills, how much you can adapt these types of things. Google Colab,
Mm-hmm.
just open it, and then yeah, create a new notebook from here.
Mm-hmm.
Just for practicing, I am telling you.
Okay.
Yeah, better idea you will get after doing practice. And then name it as rag enter, and then paste the code
Mm-hmm.
here. Here you can see
Mm-hmm.
from Langchain community CSV loader, import CSV loader. So integrate
Okay.
a specific parameters here. So your CSV file
Mm-hmm.
should be here. Okay. And
Okay.
then documents means loader dot load. It is an inbuilt function. I have told you now the dot method is used. Dot is used to
Yeah.
call the inbuilt methods like load method, other kinds of method in LangChain. So for large data set, lazily load
Mhm.
documents. So lazily load documents means
Mhm.
loading document by for loop. Load
Okay.
all documents by simply calling loader, but for large large data set, we are passing through a for loop. Means in every go, we
Okay.
are uploading the document, loading the document, and printing the document node. Okay,
Okay.
so this is how you can do practice. Here,
Mhm.
interface. Load means load all document at once. Lazy load means a stream document lazily useful for large data sets. So here you can
Okay.
see uh, document loader can be from website also. Loader means you are understanding knowledge base. We are loading the knowledge now.
Mm.
It can be from website also. Like you wanted to answer the query based upon some website information. Okay.
Okay.
So on any Wikipedia, let's suppose you have made a
Mhm.
RAG based application for a Wikipedia page which is talking about
Mhm.
independence of India. So any user will
Okay.
come and then ask the question. Apart from the
Mhm.
generalized answer, the user will get a specific answers which contest with the independence of India, which is specifically mentioned on the Wikipedia page. Okay,
Okay.
so you can
Mhm.
use
Mhm.
this kind of loader web packages also. Unstructured, retrieval, agentic QL. For document loader, these are the files by PDF. It's a package actually. So here you can see for setup API key Lang Smith, and you can see installation
Mhm.
part is this pip
Mhm.
install q langchain community py pdf. Okay,
Mhm.
so these all are the code for loading the pages like lazy load for pages. This is a this is a list now. Understood?
Mhm.
Pages is equal
Mm.
to this and this. I hope I have cleared all this in the basic Python. Like now you are able to understand. Can you explain me the code?
Yeah, basically, it is taking the list of it, and then
Correct.
um,
Append,
and then append
okay.
means adding, right?
Correct. So pages dot append is
Mhm.
adding. So one more thing you need to be very
Mhm.
sure. In Python, we don't need to worry about the data types. Okay.
Okay.
We just
Mhm.
created the list and we don't know the actual data type of the document. It's PDF na dot PDF.
Yes. Yes.
So
Mm.
in pages, it is loaded like dot append dot doc. If length of pages
Mhm.
is greater than 10, then do some operations and
Mhm.
then pages length of pages. I hope now you can
Okay.
easily uh, digest all these concepts because these are already covered in the Python basics, isn't it?
Yeah. Yeah.
Like
Yeah.
we have
Mm.
covered like advanced coffee machines and ATM machines, Python,
Yes. Yes.
isn't it? So
Mhm.
it's very easy. The only thing you need to
Mhm.
understand the working flow and
Mhm.
see how these kind of things are happen. So loader is pipe loader is a function passing the
Mhm.
address of the uh, extract the PDF by page. Each page is extracted as a LangChain document object. So docs is doc loader. So these all are the.
Mhm.
So you don't need to write and mug up all these things. You just need to be aware that these kind of articles are available on this website. So if in any case you
Okay.
wanted to do any operations like embedding models, you can go here, embedding models and see. And as per your requirement, you can simply refer these websites. These are available and open source.
Okay.
You
Okay.
just
Okay.
only need to be aware that these kind of tools are here, these kind of operations are here, and simply use a AI model also to ask and
Okay.
do the operations. Here you can see vector stores.
Mhm. Mhm.
So vector stores are different types. Similarity search and semantic search is one thing. I'm explaining you this one also.
Mhm.
So just see here. One is semantic search.
Mhm.
Semantic search. And second one is similarity search. First, I will give you a
Okay.
chance to guess. I hope you can do the. get up the answers. What it is the basic difference? Can you tell me? Semantic search and similarity search.
That means basically upon the similar type of
Correct.
search we are doing previously. Yeah.
Correct. And in semantic search,
I don't know. I think.
yeah, you are correct. Like similarity search means going rule based. Rule based approach means, let's suppose bucket, Bucket, and second but word is but. So these two words are similar or not?
Not similar.
Not similar. B, B, correct. U, correct. C,
Mm,
not correct. Okay.
yes.
Similarity
Mm,
search goes by rule based, like matching all the words by character. If two words with all the same characters means it is similar words. Okay. It's like finding
okay.
words in a dictionary. If you are searching
Mm,
bucket, you will only land up with bucket. But semantic search is, semantic means meaning.
okay. Mm,
So, there are synonyms of a single words. One
yes.
word,
Yes.
one word with multiple meanings, and multiple meanings have different. One single meaning has different words, isn't it? So, semantic search
Yes.
does not works upon this rule based. Like if something is, uh,
Mm,
let's suppose, just take it this example only, good and better. So these
mm,
two are different words, but the meaning is same, na? So these are
yes. Mm,
semantically same. Okay, good and better are of good, but semantically meaning based, these both two words are same. So these are kept into the same row of semantics
mm,
similarity semantic search. Okay, so here you can see
okay.
in vector store embedded data performs similarity search. Why similarity search in
Mm,
vector store? Because embedded data works upon the semantic algorithm. Like in embedding, we almost kept all the similar words in with the represent all the similar words with the same mathematical representation. Just a technical thing it is. In embedding, we used to do embedding of all these with a similar mathematical representation. So in vector index, when we are searching for the query, here you can see query text, embedding model, and query vector, and it does similarity search in vector store. Okay, and
mm-hmm.
it gets the top k results. One
Mm,
more thing, I'm showing you one thing here. If you'll open Gemini console, Google AI Studio, this one is. Here you can see when we'll start working on any building any model, and here one thing. Wait, yeah. See here, you can see
mm-hmm.
temperature here. Okay, the range of
Okay.
temperature is starting from 0 to 2.
Mm,
Okay, one thing that I wanted to convey here, thinking level is
mm,
high, medium, low, and minimal.
okay.
Okay, thinking level. So, can't you say like any AI ML model,
Mm-hmm.
any if you are asking any query, it can have multiple
Mm,
answers. One, two,
okay.
three, four, five, multiple answers. So,
Yes.
we can
Mm,
also see in this Google search engine, if you are searching something, how to see. I am only writing how to. It is recommending how to
okay.
take a screenshot, how to download, how to delete. Okay, in this
Okay.
and in this this tab I'm also writing how to. See here,
Okay.
how to take a screenshot, how to duplicate, how to delete page in Word. So in my case, this is coming. Okay.
Okay.
So there are multiple questions can be asked after how to, but why this is recommending? Why only these two?
Based on previous search.
Based upon the,
Previous search.
just take it. How to, see here. In this case, this is,
Mm.
so you can see here multiple types of recommendation are coming, isn't it? Based
Mm-hmm.
upon the user search option and the multiple account interaction with the Google, isn't it?
Yeah.
So basically, AI model predicts now. It is predicting that
Mm-hmm.
user is going to can be asked, can this question, can ask this question, can ask that question, isn't it? But it
Yes.
has lot more questions. Maybe hundred of questions can be
Mm-hmm.
asked after how to. But why this is showing me top three? It has some, top k elements of filter. Okay, it
Okay.
is showing
Yeah.
only those relevant questions which can be asked based upon the understanding of the model. It's not a completely smart model. Based upon the understanding, it can
Okay.
guess that these top k can be the, you know asked questions of the user. So here in Gemini playground, where I'm showing
Yeah.
you, you can increase the creativity by decreasing the temperature.
Okay.
Why? Because you are not saying your model to restrict with the input. Temperature increase means you are saying your, for Gemini the best result. See here what it is saying for Gemini.
Mm-hmm.
So basically, when you are increasing the temperature, you are restricting your model to give the exact answer that you are asking. You are not letting your model to think out of the box, means think out of your question. Okay,
Okay.
you are
Okay.
increasing the temperature.
Okay.
But if you are decreasing, you can just let the model to expand its dimension of thinking, isn't it? It's a simple words you can
Okay.
say. So these are temperatures. The lower value may impact reasoning. Yeah. So the lower value may impact reasoning because it will expand the uh, retrieval knowledge source. Okay. So the reasoning can be decreased, hallucination may increase, but you will get to see different types of answer in your output. Okay.
Okay.
But if you are increasing the temperature, you are restricting your model to stick to the question that you are asking. So these are some different
Okay.
use cases. Let's suppose if you are working on any research project, you want to get new idea, so you can decrease the temperature and let the model to expand the thinking. Maybe the reasoning can be not good, reasoning can be very poor, but the diversity will be there in the answer. Okay. So
Okay.
these are all the things. And coming to this again, so that is how top k results work. Like, model has lots of prediction, but it only show you the top k results out of the vector store. Okay.
Okay.
And this indexing phase also comes from the document embedding model and embedding vectors. So this is how the embedding function works. And similarity search, query for semantic similarity search, query for semantically similar documents. I've told you now, in embedding we are
Mm-hmm.
using semantically algorithms to store the mathematical representation. And that is then,
Mm-hmm.
first see what is happening by embedding function. Two different words are passed to the embedding function, and it gets the same mathematical representation if these two words have the same meaning. And if third one has different meaning, it will get the different mathematical, you know representation. And then it is then stored to the vector store. Fine. And
Mm-hmm.
then after this, similarity search happen, means the same mathematical representation, because we are converting the query also into a embedding function. And then after, similarity search happen. Okay. First, the
Mm-hmm.
model use embedding function, and then a stored by the help of semantically, and then similarity search is happening to find out the relevant answer. So that is here showing
Mm-hmm.
written here. Similarity search happens. Query for semantically similar documents. Understand? Understood the thing?
Okay. Okay. Mm-hmm.
Maybe it's not that much difficult. So these all are the syntaxes for initializing the vector store in memory vector, and adding documents. You can simply vector store dot add documents. You can simply refer to this article for any kind of uh, working. So now you can see these are the embedding models. Embedding models are
Mm-hmm.
there, provided by multiple companies like OpenAI embedding models. You can use OpenAI embedding model by installing this pip install, and then you can just do some practice also. I'm giving you one task. If you'll get time, just go through this documentation. It's
Okay.
very well written documentation, and all the things are clearly
Mm-hmm.
written here, like top embedding models you can use by text embedding 3 large. This is a model in
Mm-hmm.
OpenAI for embedding, and OpenAI API key you need to give here. For Gemini, syntax will be same: import get pass, import OS means operating system, and if not os.involve. I don't think that these syntaxes are now difficult to understand for you, because we have understood all this now. File handling in Python we have already covered, isn't it?
Yes. Yes. Mm.
Have you seen the read write operation in Python, file handling?
Yes.
I
Yes.
have shown you now by doing practical implementation. So
Mm.
these are basically that thing. If not os.environment.get Google API key, you have to paste your Google API key here, and then you have to
Mm.
pass through the, see, embeddings in generated. This is embedding which will
Mm.
be generated by passing your text through this model,
Mm.
Google Generative AI embedding. This is a function call.
Mm.
Okay, and this is made by Google Gemini. We don't need to worry about how this embedding function is working, because this is created by top Google employees. Okay, so
Okay. Mm-hmm.
they are providing this. We just need to use these applications to create our application. So
Okay.
these are the models, Gemini embedding 001. You can see multiple models here of Google Gemini also, and you can also use
Mm.
Hugging Face models which are free, but the accuracy will
Mm.
have hamper in this, because these are free models,
Mm.
and when you will do the same operation by this model, your output will not be at that much accurate as compared to the OpenAI or Gemini model. Still you will get Hugging Face. So for a scalable application where company does not have the budget to expand their project, like Google and Gemini
Mm.
will charge you after a limit, but Hugging Face is free. So if company does not want to invest in that much amount, so they can use this Hugging Face free model, like embedding model, sentence transformer, to utilize the RAG application. IBM Watson X, which NVIDIA embedding models are also there. So NVIDIA
Mm-hmm.
embeddings you can use. So the model behind this is NV Embed QA. So these are the
Mm-hmm.
embedding models. So, and searching vector store, these are the searching. Everything is pre-built. Okay, you just need to collab all this and work on that.
Okay.
Document loader integration you have seen. Retrievers. I've already explained you all this.
Mm-hmm.
Now coming to this part, chat models. See here, uh, tool calling a structured output and multi-model. So chat OpenAI. You can just go through. I'm sharing you this website first.
Mm-hmm.
Okay. So bookmark it first in your tab, and whenever you get time, just go through, because this is the, okay, all this fine. So now I'm also showing you the code here for RAG application. GitHub. Wait, yeah. Mm, document loaders, yeah, fine it is. These all are the popular providers of the
Mm.
applications. Graph, RAG. Okay. So the task is for today's session, after today's session, is to build the RAG application, and I am showing you the exact that page where you can
Mhm.
use that. Yeah, maybe it's not here. So let me share my own repository to you. So
Okay.
Google would have, maybe they have. So for today I'm just winding up the session here. I'm just giving you tasks now. Okay. For
Mhm.
theoretical aspects I've covered lots of things.